Hey, and welcome back. So those of you just joining us, welcome back. If you're binge watching my lecture notes, yeah, take some break, do some stretching, because continuously watching some videos is not very good for your health. Anyway, we'll get started. So in this video, we'll be looking at sets, basics, and methods. So you probably remember using sets in mathematics, and similar concept really applies in programming. So let's have a look how we can use sets in Python. So we're going to do a quick recap on lists and tuples. So if you remember lists and tuples, they kind of allow you to have a collection of items, but we have this specific data set called sets, and these hopefully will make you understand why we want to use sets instead of lists or tuples. So lists are a mutable collection of objects, so one's in the square brackets, while tuples are immutable collection of objects, one's in the round brackets. So one you can change the content, the other one you cannot, right? So let's have a quick look at using lists. So hopefully this will be familiar to you. We can create a list as such in a square bracket, and then we can add new items into a list. We can also check what's at specific index at a list. So at index 3, we have a country called Belize, right? So if we look at countries, we have 4 countries, and index 3, the last one, is Belize. Also, we can try to find countries.index of a place. If it doesn't exist, then it's going to fail. Ooh. I didn't print it, so that's probably why. So let's put it into print. Then I should see index 2 as expected, right? And you can expect the same thing happening with using tuples, right? So these are all fine, but we have one significant problem using these guys as a collection of data, especially when we're trying to look up things quickly, because these are what we call order n data structures. So you don't have to be familiar with this notation, but it essentially means if I want to find an item inside a list, given an n number of items, then it's going to take me n. It's going to usually take me to check n items to find what I want. Okay, and in terms of searching algorithms, that's not really quick. We can do much better. For example, say you have a phone book that has been arranged in the order of numbers, or say, for example, arranged in the last name of a person, and then if I give you a name to find the person's phone number, then you can easily find it much faster by skipping through a lot of other names, right? So that's the same idea here. We don't want to check every single item, but possibly we can skip a lot of them and get to the item that we want. Okay, so that's the kind of concept of sets. It allows you to index things much faster. So sets are essentially a collection of unordered and distinct items. So what that means is when you create a set and you have a bunch of duplicated items, then you're going to be removing all those duplicates when you convert it into a set. Sets are mutable, so that means it has the similar properties as list, where the content of the set can be updated as you go along, but all items must be immutable. So each item that you store inside a set cannot be changed during an operation. Something is either in the set or it's not. So that's a very clear distinction, but this kind of applies in the list and tuple as well. You can't have maybe in the set or maybe not in the set. This is very fast due to hashing. So if you're not familiar with the term hashing, you could look it up. However, it is not a requirement in this unit, so you don't have to fully understand what hashing does. So given these properties, because it's very fast to look up things, this is very useful for things like membership testing, whether an item belongs to a set or not, removing duplicates, and general set math like intersections, union differences, etc. So it has its own benefits of using the sets. Okay, and then create it with sets and 0 or 1 iterable arguments, or with an item lists in braces. So this is how we go about creating sets, especially an empty set. So let's have a look at some examples. Hide these guys. We'll open one at a time. So we can create an empty set using a set function, default inbuilt function. So we can create an empty set. So empty set is telling me it's a set. You can try to create a set using square brackets. However, using not the square brackets, sorry, curly brackets, but curly brackets are actually reserved name for dictionary. So if I do that and go empty set, then this is actually a different data type. So we can check type of empty set is a class dictionary, which we'll cover in a couple of videos later. So let's create our empty set back and check type of the empty set. Then this is class set. Okay, so just be careful when you create a set in Python. You have to use either the set constructor or have some items, as we will see next. So here, let's create farm animals, for instance. Then you can also pass in list as an input to this set function. Okay, then this is going to create a set of farm animals for us. Okay, so here you can see that when it presents the set items, it is inside the curly bracket, which by mathematical form, it's consistent with that, right? If you pass in, for example, like strings, then similar to list, is going to individually store each character as part of the set. So when we look at alphabets, it's going to create each letter on its own. Here you should notice that the order of alphabets now have changed. So here, before we passed in A, B, C, D, E, F in order, but when we actually check the contents of the alphabet now, it has shuffled around. This is due to hashing, and hashing is used to put them in the slots in the set. However, we'll have a look at that in a couple of slides. Okay, and finally, pets is another set. Again, you can see that the order of items has been changed slightly. So when you put stuff into the set, make sure that you can't assume things will be in the order that you put them in. Okay, and testing membership, just like using lists, you can use the in operator to check whether things exist or not. So we can check things like is pig in farm animals? Then it's going to tell me it's true, because farm animals, when we created it, we did have a pig in there. We could also have check pig in pets. Then this is going to be false, because our pets don't consist of pig. Okay, so the usage is pretty much like lists. So why do we want to use sets instead of lists, right? So let's have a look at our next set of code. So we mentioned that using set is much faster than using list. Okay, so this should test how quick membership testing is compared to the list. So this is the code that we have. So what we're going to do is here we are using list, and we're going to run this. So what it does is create 20,000 numbers and then check how long it takes to just create some numbers and find each one at a time. So run it, and if you wait for a while, then this is going to complete. Oh, here we go. Yay. So it only took 7 seconds. So you might think that that's actually not that bad, but as soon as we increase this number, you can try this by yourself, say 100,000 or even 1,000,000, then you will have to wait actually a long time to find each item. So instead, what we're going to do is, instead of this list, we're going to update it to using set. So the way we create a set is similar to the list, so we can pass it into the set function. Then this is going to create a set for us. And if you run this, how long do you think it's going to take? Maybe 2 seconds. Okay, if you guessed under a second, you're absolutely correct. So this one took, say, 0.01 seconds. So compared to 7 seconds that we had before, this is roughly about 700 times faster. And if you increase that number, you'll see the gap increases more and more. Okay, so exactly how does this happen? How can we use set such that it can look up items much faster? Well, basically, this is the way the hash function works. What it does is it puts the item into the hash function and calculates some number. And this number is going to be used as indexing of the item. So when I have to look up something else later, what do I have to do is, rather than going through each item in the list, I put it into the hash function. This is going to calculate me the number for that item. And then I check whether that item is in the box or not. Then, if it exists in the box, then I can say that this item exists in this box. Otherwise, it's not present in my set. Therefore, I don't have to actually check any other numbers, any other boxes. All I have to do is calculate the number and check whether it's there or not. I don't have to look at any other boxes to check because I know this one, if it is in there, it has to be in this particular slot. Okay, so that's the the magic of hashing trick for using the sets. And what we say is this is order one. That means if I want to look up something in my set, then I have a constant time of looking it up rather than going through the whole list. However, you don't really have to know how this the order one or order n things work. You can cover more about that in CITS2401. All right. So now let's have a look at some basic methods of set. So sets do provide some basic methods. So let's start with add. So I want farm animals and pets. That's what I want. And I want to hide these guys. Okay, run. Good. All right, so now I have farm animals, okay, which contains 3 types of animals. So what I want to do is dot add cow. Okay, so that's very easy to do. Just like the list append, instead sets will have add. Okay, I can also add horse, for instance. Now the farm animal contains 5 animals. Again, you can see the order of animals has changed quite rapidly. So first I have goat, pig, dog, goat, pig, dog, and the cow and horse has been inserted into different places. Okay, so do note that the orders don't matter inside a set. Okay, you can also remove things by using the remove method. Dot remove. Now I don't want horse anymore, so I can delete it and check. Now the horse is gone. Okay, so that's how you add and remove items inside a set. Very straightforward. Otherwise, you can also clear the whole set. You want to get rid of every items, then you just have to call dot clear method. Then the set is going to be an empty set again. Okay, I'm just going to run it. Have cow in there. All right, so now let's have a look at the mathematical notations about using sets. Things like union, intersect, difference, etc. Okay, so all those names actually come pretty much the same as your mathematical notation. So union is all the items in both sets, and you can use it as a method of the set. So for example, farm animals dot union, and the input will be another set in here. So I have pets. So it doesn't matter whether I put farm animals or pets at the front, the resulting answer should be the same. So here, and then I can try pets dot union farm animals. It's gonna return me the same item. However, the order can be slightly different because the way you add things onto the other set may be different. However, that is not the concern for us. It's all handled by Python. Okay. Intersection, same thing. However, now we're looking for animals that belongs to both sets. So we could do not union, but intersection. You have to write out the full letters. Okay, and in this case, dog belongs to both farm animals and pets as well. Okay, so hopefully that's quite straightforward. Okay, difference is well, basically the items in my set minus the ones that belongs to both sets. Okay, so this one does matter how the order you put it in. So before that, it's always looking for a common ground for both sets, but this one is looking for one specific set. So it does matter which order you put it in. So difference. Okay, so pets.difference farm animals is cat, goldfish, and gerbil. Is it gerbil? Gerbil? I don't know. But farm animals dot difference pets is going to give me pigs, pig, goat, and cow. Okay, so this particular difference method is specific to which one you use first, and going to show you the items belonging to that one and that one uniquely only. Okay, symmetric difference. This one is also one that you can use whichever order you want. Pets dot symmetric difference farm animals. Okay, so this one tells me all the items inside both sets which are not common to both of them. So unique to both A and unique to both B as well. Okay, so these methods would come useful if you have some type of questions where you need to find some memberships belonging to one or more, and you can also apply this in addition to another set. For example, because the returning value out of these methods is a set, you can apply this set to have another method associated with another set. Okay, but you will cover that during the labs, right? And checking the set relationship is quite straightforward as well using the is subset method. So for example, I have my pets equals cat and dog. Okay, so this is my specific pets, and what I can do is check whether my pets is a subset. My pets dot is subset of pets. Then this is true because all the pets contain both cat and dog, right? And also you can check the superset. So pets dot super is superset of my pets. Okay, so this checks whether the invoked set contains all the items inside the input parameter set that we pass in. Okay, so this should be quite straightforward. All right. And for some of these methods, we can apply operators. So like the set differences, we can use a minus. For intersections, we can use an and, ampersand. Is subset is less than equal to, is superset is greater than equal to, so I can go my pets is a subset of pets. Okay, so the same result as before, and pets is a superset of my pets. It's true, right? Union is done by the straight line. So this is the one above your enter key normally in your keyboard. And symmetric difference is using the head operator. Okay, so you can use these operators rather than typing out the full method names, which is more handy. There is one thing that is missing, which is a union. So basically, union, you will have to write out the full method name because it doesn't have an operator assigned to it. Why do you think the plus sign is not used for a union? You can think about that by pausing the video. Or basically it has a potential ambiguous, whether it's an insertion or a union, right? So whenever something is not used for something, it's because due to its ambiguity. All right, so this is it for this particular video, looking at its basics and its method. Otherwise, I'll see you in the next one. Bye bye.